Okay children, so the scientist Millikan, by means of oil drop experiment, this is not much important, it is given in your textbook in a small box, you can just go through it once. So Millikan, by means of oil drop experiment, he determined the charge of electron as minus 1.6 into 10 power minus 19 coulombs. Why there is a negative charge here? Because you may know electrons are negatively charged, that's the reason why there is a negative charge here. So he found the charge of electron, the value for charge of one electron is minus 1.6. Okay, now what is the mass of electron? Okay, so we identified that Millikan, through the experiment, oil drop experiment, he has determined the value of charge of electron as 1.6 into 10 power minus 19 coulombs. Now what happens to the mass? Because my objective is to determine the charge by mass ratio. What is the mass, children? So mass of the electron is equal to charge of the electron by electron. This is also nothing but your charge by mass. I think this was determined by the scientist previously. I think this was determined by the scientist Thomson. Thomson has discovered the charge by mass ratio of an electron was 1.7588 into 10 power 20. And what is the charge of electron which was discovered by Millikan? It is found to be 1.6022 into 10 power this value. So when I divide the charge of the electron by charge by mass ratio which was obtained by the scientist Thomson, it was 1.75. So now what is the mass of one electron, children? The mass of one electron is said to be 9.1094 into 10 power minus 31 kilogram. Children, this will be a definite question because in almost most of the papers, you will be getting this particular question. That is, what is the question, children? What is the mass of the electron and what is the charge of the electron? Okay, so we have determined that. Next, moving to the photoelectric effect. I have explained photoelectric effect in one of the session, but these are some of the extra points which I want to highlight. Okay. Photoelectric effect. Okay, from the question itself I got the answer, photon. So light energy is there. Electrical effect, so electrons are also involved. Children, I have a metal. What is this metal? This metal can be potassium, cesium or rubidium. So what is the metal? I have a metal surface which can be potassium, cesium or rubidium. When a beam of light strikes the metal surface, electrons are ejected. This is your photoelectric effect. This was discovered by the scientist Hertz. Clear to you? So what is photoelectric effect? When a beam of light falls on the metal surface like potassium, cesium or rubidium, electrons are ejected. Photon, light energy, striking a metal surface, electrons are emitted. Photon, electron, photoelectric effect. So this is called as photoelectric effect. This was discovered by the scientist Hertz. Okay. Now, what is the results of photoelectric effect? See, there is no time lag between the striking of light beam and ejection of electron from the metal surface. There is no time lag. The moment my light is going to strike the metal surface, immediately electrons are ejected. So what they want to infer from me, there is no time lag between the striking of light, beam of light and the ejection of electrons. This is your first point. Clear? Now, the number of electrons ejected is directly proportional to the intensity of the light. Now, how many electrons will be ejected? This depends upon the brightness of the light. What is intensity? Intensity is nothing but your brightness. So, number of electrons ejected depends on the intensity of the light. Clear to you? What is the third point? For each metal, there is one frequency. That frequency is called as threshold frequency. What is threshold frequency? It is nothing but a characterized minimal frequency. So each and every metal will be having a threshold frequency. Threshold frequency is otherwise called as characteristic minimal frequency, because below your V dash there will not be photoelectric effect. Clear to you? So each and every metal has a threshold frequency below which you cannot observe photoelectric effect. Okay. Now, when the frequency is more than V0, when my frequency is greater than threshold frequency, then ejected electrons will be coming out with kinetic energy. When my frequency is more than the threshold frequency, then only what happens, my electrons ejected will be coming out and they are in motion. So which energy they possess? They should be possessing a kinetic energy. So the scientist Einstein, he explained your photoelectric effect using Planck's quantum theory, where kinetic energy of the ejected electrons is given by the formula h mu is equal to h mu dash plus half mv square. What is h? H is nothing but Planck's constant. This is the frequency. This is the threshold frequency. This is the mass of the electron, and v is the velocity of the electron. So clear to you? So what is photoelectric effect? When a beam of light is going to strike the metal surface like potassium, cesium or rubidium, then electrons will be ejected. And the number of electrons ejected is directly proportional to the intensity of the light. There is no time lag between the ejection of electrons and the falling of the beam of light. Okay, when the moment the beam of light strikes the metal surface, immediately the electrons will be ejected. And when the frequency is more than the threshold frequency, only then the electrons will be coming out with kinetic energy that was given by the scientist Einstein. What is that equation? H mu is equal to h mu dash plus half mv square. Clear? Then what is quantum mechanical model of atom? What is quantum mechanical model of atom? Children, the classical mechanics, this is quantum mechanics. What is classical mechanics? The classical mechanics was explaining very well about the motion of macroscopic objects. What it was explaining? It was explaining about the motion of macroscopic objects. This is by classical mechanics. But what is the special in quantum mechanics? Because quantum mechanics is nothing but a branch of science that deals with the dual behavior of the matter. So what is quantum mechanics? It is a branch of science. It is going to deal with the dual behavior of matter. The two behavior of matter which I have already explained about you, that is wave nature and particle nature. So my quantum mechanics is going to deal with the dual behavior of matter. Clear to you? Now it is otherwise called as a theoretical science that deals with the motion of microscopic objects. As I have already explained you, classical mechanics was explaining about macroscopic objects like falling objects, while your quantum mechanics is a special branch of science which is going to deal with the motion of microscopic objects which you cannot see, like it is atoms, molecules, electrons. Because we know already that all these objects like atom, molecules and electrons, they have both wave nature and particle nature. So any science which deals with the study of motion of microscopic objects is collectively called as quantum mechanics. This is collectively called as quantum mechanics. And the quantum mechanical model of atom was explained by Heisenberg and Schrödinger's. They both together explained the quantum mechanical model. But of Heisenberg and Schrödinger, Heisenberg has separately explained about Heisenberg uncertainty principle, and Schrödinger explained the fundamental equation of quantum mechanics, for which he was awarded the Nobel Prize. I have told what is the Schrödinger's equation. E psi is equal to h psi, and what is that h? H is nothing but Hamiltonian constant, which I have discussed in the other sessions. So what is quantum mechanics, children? It is a science that deals with the motion of microscopic objects like atoms, molecules and electrons, and Heisenberg and Schrödinger have explained about this. Okay children, I just want to summarize in this chapter what I have covered. See, this chapter, structure of atom, there is no much continuity in the chapter because there are separate topics in the chapter. At first, I have covered the topic like discovery of subatomic particles. In that I explained about protons, electrons and neutrons. Of all the three, we have some significance to the discovery of electrons, which we have seen in the previous session. That is your cathode ray discharge tube we have seen. Then charge by mass ratio we saw. What is the charge of electron and what is the mass of electron we have seen. Okay. Then we studied about atomic models, like what are the atomic models. In that we saw about the Thomson's plum pudding model, and then we saw Rutherford's model. Then we saw what are the drawbacks of Rutherford model. So whenever you think about Rutherford model, think about alpha rays and gold foil experiment. Okay. So what are the drawbacks of Rutherford model also we saw, because your moving particles gain acceleration as they move in the circular path, they gain acceleration. So what happens? We have seen second model. And what is the third model? We saw the developments leading to Bohr's theory, and what is Bohr's theory we saw, and what are the drawbacks of Bohr's theory, what is the achievements of Bohr theory. So we have completed atomic model. So discovery of subatomic particles over and atomic models over. After that we saw about the hydrogen spectrum, because Bohr explained about hydrogen spectrum and the lines involved, the Balmer series, Lyman series, Pasteur, okay, all those series I have explained. So hydrogen spectrum was explained by the Bohr, so that was taken into a separate concept, and we explained about hydrogen spectra. Then we studied about electromagnetic radiations, that is EMR, electromagnetic radiations, under which we were seeing about black body radiations. And we saw about electromagnetic spectrum. What is electromagnetic spectrum also we have seen. Okay. Then we what are under the drawbacks of Bohr's theory. Bohr's theory was not able to explain about Heisenberg's uncertainty principle. It was not able to explain Schrodinger's equation, quantum theory. So we saw each one by one. Okay. We saw about Schrodinger's equation. We saw de Broglie's equation. Okay, done. Then we saw rules for filling the orbitals. Before that, what is quantum numbers? I explained about the 4 quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. I explained what are quantum numbers. Then I explained about what is orbit and what is orbital. That also I have explained. Orbit and orbital difference also we have seen clearly. Then we saw about the shape of the orbitals. We saw the shape of s orbital, we saw the shape of p orbital, then we saw the shape of d orbital. F orbital is not explained in the textbook, so we have left out F. So we have clearly studied S, P, D, F. S is spherically symmetrical, and P dumbbell shaped, and F is also, D is also like that, S, P, D. Then how many electrons will an s orbital hold? The maximum number of electrons which your s can hold is 2, then your p can hold 6, then your d can hold 10, and your f can hold 14 electrons. It goes like that. Okay, we have seen that too. Then what is the value of s? S is equal to 0, p is equal to 1, sp, d is equal to 2, f is equal to 3. We have seen the values also. So we saw the difference between orbit and orbital. We saw what is quantum numbers. We saw what is the shape of the orbitals. Then we saw rules for filling the orbitals. In that we saw 3. Auber principle, then we saw Hund's rules for multiplicity, then Heisenberg's uncertainty rule, like no 2 electrons, like how to fill, like all the subshells should have at least 1 electron each, not all that should possess same number of quantum numbers, like that we saw all the rules for filling the orbitals. Then we saw about isotopes, and we saw about isobars. Then children, about the electronic configuration, that's also a definite problem in this chapter. Suppose you know the nitrogen's number, atomic number is 7, then how will you fill that? As I told you, you need to remember a sequence. Okay, what is that sequence, children? See, this is the sequence which you are supposed to memorize. How will you fill the electrons in these orbital? Okay, 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p. How to remember this? We have a small shortcut to remember. And I have told you, see, between your 3p, for example 3d and 4p, which should be filled first, for that also I have explained. 3d, the max n is equal to 3. What is the value of d? You need to fill it and check, like which is having the orbital having lower number should be filled first, and orbital having higher number should be filled last. That also I have explained with the 2 examples. Now how to remember this, children? See, number alone you need to remember one, because it is in sequence only, 1, 2, 3, 4, like that only it is happening. I am just trying you with a small acronym, something like acronym. See, school, SS, no? So school, public school, Delhi public school, Federal Delhi Public School, Federal Delhi Public School, it goes like that. Okay, shall I repeat it for you? What is that? School, school, public school, Delhi Public School, Federal Delhi Public School, and it goes like that. Okay children, I will be sending this song also for easy remembrance, so that you will be remembering the particular sequence. So till if I say chromium's atomic number, just write the electronic configuration, then you should be able to fill the electronic configuration. There are few problems which I will be sending you in the form of scanned notes. That is very easy only. Like I will be knowing the value of n, I will be asking you to determine the value of m. So I have explained in the 4 quantum numbers, like what is the preferable values for each quantum number and what is the range of the quantum numbers through which you can easily determine. I have solved enough number of problems, almost 10 to 12 problems, all which is easy only. I will be sending you in the form of a scanned notes. And whenever we are getting a live session, I will be clarifying all your doubts in that. Okay children, thank you. And children, there is one last topic which I didn't think, that is filling of partially filled and half filled orbitals. That's a small topic which I will be dealing in the next session. Thank you.